Have you ever wondered why buildings don't simply sink into the ground, or why skyscrapers don't topple over in strong winds? It's a question that may have crossed your mind, and the answer lies in the magic of foundations. Foundations are more than just lumps of concrete buried in the ground. They're the unsung heroes of construction, distributing the weight of structures evenly across the earth beneath. But it isn't as simple as just laying down a foundation and hoping for the best. No, there's a science behind it. That's where the importance of calculating structural loads on a foundation comes into play. This calculation ensures the stability and longevity of a building, preventing it from becoming a leaning tower of disaster. Imagine a foundation as a team of diligent workers, each carrying a share of the building's weight. It's the task of civil engineers to ensure that this weight is distributed evenly among the team, preventing any one member from buckling under pressure. So, understanding how to calculate these loads is crucial for any civil engineer or anyone interested in construction. Now that we know why it's important, how do we actually go about calculating the structural loads on a foundation? Structural loads, in essence, are the forces that a structure must withstand. They come in three primary types: dead loads, live loads, and environmental loads. Let's break these down. Dead loads refer to the weight of the structure itself, including the foundation, walls, floors, roof, and any other permanent fixtures. Think of this as the structure's self-weight. To calculate dead loads, we need the volume of each component and its material density. By multiplying these two, we get the weight. For example, if a concrete wall has a volume of 3 cubic meters and the density of concrete is 2,400 kilograms per cubic meter, the dead load of the wall is 7,200 kilograms. Next, we have live loads. These are temporary loads that the structure experiences, such as people, furniture, and movable partitions. The calculation of live loads depends on the intended use of the structure. For example, in a residential building, we might consider an average weight of 75 kilograms per person and an allowance for furniture. Lastly, we have environmental loads. These are external forces that act on the structure, such as wind, snow, earthquakes, and even soil pressure. The calculation of these loads is a bit more complex and depends on local building codes and climate data. For instance, wind load is calculated by considering the wind speed, the building's shape and height, and the surrounding topography. But how do we bring all these calculations together? Well, we use load calculation formulas. These formulas consider the different types of loads and their magnitudes to calculate the total load on a structure. For example, the total load might be the sum of the dead load, the live load, and the environmental load. These calculations are crucial in determining whether a structure's foundation can safely support the expected loads. Accurate measurements are the backbone of these calculations. Even a small error in measuring the dimensions of a structure or estimating the loads can lead to significant errors in the final calculations. Therefore, precision is key. It's also worth noting that these calculations are iterative. As we refine the design and make changes, we need to update the load calculations accordingly. It's a dynamic process that continues throughout the life of the project. To sum up, calculating structural loads involves understanding the different types of loads, using accurate measurements, and applying appropriate load calculation formulas. It's a meticulous process, but it's vital for the safe and effective design of any structure. Remember, it's not just about numbers. It's about ensuring the stability and safety of the structures we build. Let's recap what we've learned today about calculating structural loads on a foundation. The importance of this cannot be overstated. It's not just about knowing the weight of the building, but understanding the different types of loads that a structure must withstand. These include dead loads, which are the weight of the building itself, and live loads, which include the weight of people, furniture, and weather conditions. The process of calculating each load is meticulous and requires careful attention to detail. Every element, from the materials used to the environmental conditions, must be taken into account. And remember, accuracy is paramount. A miscalculation could lead to structural instability, and in the worst case, a catastrophic collapse. So next time you see a building, you'll know there's more to it than meets the eye. The stability of that structure relies heavily on the unseen calculations of structural loads on its foundation. Until next time, keep building your knowledge. Thank you for watching. Please follow and subscribe for any videos next.